Okay, have a good evening for all my students. Okay, now we would like to continue our study regarding the manufacturing technology. This included chapter 3. It's called metal casting. Everyone know that all the manufacturing technology have their advantages and disadvantages. For example, previous education, previous lecture, we have machining, we have casting, we have high speed machining. So by today I would like to discuss with you and sharing with you what is the metal casting. As you can see from this movie, we have a lot of casting technology and a lot of product. How that it can be made? Of course it made by metal casting, including the precision parts, automotive, its engines, including the wheel and the disc, and also the body, and how it pour become from liquid to solid. We are gonna to share with you. Okay, fundamental of metal casting. Actually, the metal casting is important in manufacturing global area. Some of the part is must to be in casting because the constraint of the mass production. For example, we cannot do a engine part with a machining, totally machining, because it takes time. That's why we have to use a casting. So in 1 minute we can produce about 10 to 20 of engine cover if we're talking about an automotive. And we are going to cover the solidification of molten metal, how we are gonna make a liquidization of the metal from solid, and we pour to the mold and we do some analysis. What is analysis? This means how the metal is came from the liquid. Actually it came from solid and it melt. When it melt, we pour. When you do some analysis, how it's going to fill all the mold. In some of the graph we can discuss, is it possible that it will be a solidification faster or slower? What is the advantages and disadvantages? And also the fluidity of the metal pouring. And we're going to cover also solidification and cooling as well, that every metal have their own properties to solid. It depend on the shrinkage and also the directional solidification. And metal casting, this is the advantage of metal casting, that produce eternal cavity hollow solution. So it's easy. So I'm going to show you the part. It's easy to understand, a very large part, and also can utilize. Actually, if we have for example 10 kg of material, so we use all the 10 kg of material to make the part, rather than the machining. We have a 10 kg and we are gonna remove about 50 to 80 will be a waste. Also they can create a both external shape same simultaneously, and some casting process and other than that shape. Okay, but we have the disadvantage, actually limitation of property sometimes, because it came from solid, goes to liquid, and goes to solid again. So some of the properties have some weakness on that. And poor dimensional. Why is called poor dimensional? Because it has shrinkage. We cannot control, and also it's hard to control the dimensional, because it will be a shrink and or it will expand. But some of the technique we can do that, but in general we say that it's poor dimensional. And safety hazard, of course, it's very hot, and some of the hot things will have a high risk to a worker. And also the environmental problem is one of the least that we are going to highlight later. This is the part you're gonna list that part of the made by casting, from the engine block, vehicle, automotive, foot burners to wheel, pipes, and pump housing. You see around of you many and plenty made by casting, and small part is dental crown, jewelry, small statue of frying pans, and some of the very metal, including the ferrous and non-ferrous. So this is a cooling curve of pure metal, how it's gonna go down, and like, so you see like the hot T is a temperature time, and this is time, so it pouring temperature is liquid coolant. When it feel the mold, it will coolant and give freezing beginner. So this is local, so this is the time. After that we make it heat, so it's still call it coolant. Actually this is not like just one time and call it. We have one down we call liquid cooling, one also second phase we call solid cooling. They have a two phase in order to make from solid liquid to solid. So this is what is happens in a grain structure inside. The step and level is gonna make some different between of them. A, B, C, you know, it depend. Of course, it depend on the grain structure, but it depend how the liquid cool. Solidification time will takes time. Is this, I'm really guarantee that actually solidification time is, can say that estimation. We cannot go exactly that in a microsecond or micro minute or microsecond, because you know that how we measure on time and very subjective. If you're pouring the metal in a room temperature, different, but if pouring to the lab that have a air conditioner, even though that the temperatures in the liquid say that, for example, 100 Celsius, but it will cool faster rather rather than the room temperature. Okay, more constant of Kyoto rules is more, we have a constant, we can say it's a more material, thermal properties and casting of the material.